Lesson 8C, Force and Momentum. Recall Newton's first law. F net equals mass times acceleration, where acceleration equals F net divided by mass. Our kinematic equations include the equation for acceleration. A equals change in velocity divided by time interval. Acceleration equals v final minus v initial divided by time. When we combine these two, we have F net divided by mass equals change in velocity divided by time interval. If we cross multiply the denominators, we have F net times time interval equals mass times change in velocity. Now remember, mass times change in velocity was defined in last lesson as a change in momentum, also known as impulse. What we have is F net times time interval, which equals mass times change in velocity, which in turn equals to impulse. If we look at this statement closely, we notice that if we apply an unbalanced force on an object for a period of time, F net times delta t, then we can change the object's velocity, which changes the object's momentum, which is impulse. The unit for F net times time interval is Newton seconds, which is equivalent to kilogram meters per second. Conventionally, we use Newton seconds for impulse measurements and kilogram meters per second for momentum measurements. Just another reminder that momentum problems can involve changes in direction, so proper vector notation, using the proper negative and positive signs for vectors, are important. Going back to our baseball example where the ball was struck and its velocity changed from positive 38 to negative 55 meters per second, using our impulse equation, we calculated that the change in momentum would be negative 13.02 kilogram meters per second, which we would report as negative 13.02 Newton seconds since its impulse. Using this example, what would the unbalanced force from the bat acting on the ball to result in this change in momentum if the ball was in contact with the bat for 0.80 milliseconds or 8.0 times 10 to the negative 4 seconds? Earlier in the lesson, we determined that impulse equals net force times time interval. Isolating for force, we have impulse divided by time interval. Subbing on our values of negative 13.02 Newton seconds and 8.0 times 10 to the negative 4 seconds, we have force acting on the ball is negative 16,275 newtons, where the negative sign means the force is applied to the ball in the opposite direction that the ball was initially traveling. We can go a further step and determine the acceleration of the ball due to its contact with the bat that applies a force of 16,275 newtons of force on the ball. Remember, F net equals mass times acceleration. Acceleration equals net force divided by mass. Force was negative 16,275 newtons, and mass on the ball was 0.14 kilograms. Acceleration is 116,250 newtons per kilogram, or equivalently 116,250 meters per second squared. Our second example is of two eggs dropped from the same height. One is dropped onto the floor, while the second into a bucket of water. Why does one egg break while the other does not? For both eggs, mass, velocity final, and velocity initial are the same. This means that the change in momentum, or the impulse, for both eggs will be the same too. Well, what isn't the same then? The time interval for change in momentum. The egg hitting the ground must change velocity from velocity initial to velocity final of 0 meters per second almost instantly, while the egg landing in the bucket has more time to reach its final velocity of 0 meters per second. If we take our impulse equation and isolate for force, we have force equals impulse divided by change in time. We see that the smaller the time interval, the greater the force. We also notice that the larger the time interval, the smaller the force. So for the egg drop, mass, final, and initial velocity and impulse are all the same. But what is not the same is time interval and force net. In this video clip, space equals time.
Lois Lane is falling, accelerating at an initial rate of 32 feet per second. Superman swoops down to save her by reaching out two arms of steel. Miss Lane, who is now traveling at approximately 120 miles an hour, hits them and is immediately sliced into 3 equal pieces.
Unless Superman matches her speed and decelerates.
In what space, sir? In what space? She's 2 feet above the ground. You know, frankly, if he really loved her, he'd let her hit the pavement. It'd be a more merciful death.
This same premise is used in airbags in cars. Increase the time for the deceleration, which in turn decreases the force acting on the body. We see this idea of force and time in sports as well. Why do coaches tell you to follow through when hitting a tennis ball, volleyball, or when kicking a soccer ball? When following through, you maximize the time the force applied is in contact with the ball, which creates a greater impulse. In sports like volleyball and basketball, why do we ask you to land with bent knees? If you bend your knees when you land, you will increase the time it takes for your body's velocity to change, which reduces the forces acting on your body, like your knees, which will minimize injuries due to these forces. What does rolling with the punches mean? Boxers are trained to roll with punches, which means when they are struck with a punch, especially to the head, they should let their head roll backwards to maximize the time the head absorbs the punch, allowing for the force to be lesser, but for a greater amount of time.